OK, so here's what we're going to do. So I'm going to walk you through what it looks like when main calls foo. And it's 6 steps. So the first step, we are going to push arguments onto the stack. So say main has some arguments that it wants to give to foo. It has to pass those arguments to foo somehow. And there's actually lots of different ways you can do this. You could use registers. Main could, I don't know, like pick up the phone and tell foo what the arguments are. But in x86, the conventional way to pass arguments is to put them on the stack. So let's say main has 2 arguments for foo. What we're going to do is we're going to push those 2 arguments onto the stack. And remember, when you push things onto the stack, ESP goes down. If we didn't shift ESP and change its address to be down here, these 2 values would have been below ESP. They would have been in the abyss. They would have been in undefined parts of memory, and we don't want that. So when I push arguments, I push them on the stack, ESP goes down. A very tiny little piece of fine print is that arguments are pushed in reverse order. Not too important, but that's what x86 does. So we have pushed our arguments onto the stack. OK, next step. So now I want to start changing all these registers. I want to move EBP down here. I want to move ESP down here. I want to change EIP to point at foo. But I can't just start going and changing all these register values, because if I do, I'm going to forget what used to be in those register values. So before I can change anything, I always have to write down the old value. That's the second time that I've said that. So let's see. What's a value that I'm about to change? I would really like to change this EIP, because right now it's pointing at main. I want to change this to the address of the instructions of foo. So I want this box to hold the address over here. But I can't just go to EIP and overwrite what used to be there, because then I'll lose the old value. So what I have to do is first take this old value and write it down somewhere. Where do I write down the old value of ESP? If only there was some place where I could write down values. Well, there's the stack, so that's what I'm going to use. So what I will do is this EIP value, whatever value used to be here, I'm just going to take those bits, the 1s and 0s, I'm going to copy them onto the stack. So here they are. They're living on the stack now. This is me saving my work as I go, so that later, if I change EIP, I can change it back when I'm done. So here's EIP. I take these bits, I copy them on the stack. You'll see that this arrow now points to the same place as EIP. Both of these boxes hold addresses, and they hold the address of the code for main. So what I have done here is I have pushed the old value of EIP onto the stack, so that later, when I'm done, I can put this original value back in the EIP register. It's a very long-winded way of saying I saved my work as I went. And as always, when you push something, ESP goes down. So that's step 2. I wrote down the value. And now that I've written down the value, I am clear to move EIP, because I know the original value. So what's something else I have to change? I also want to change EBP. So that's what I'm going to do. So I want to change EBP. I don't want it to point up here. I want to make a new stack frame like we saw from earlier. But it's not OK to just take this value and clobber it out with a different value. I actually need to take this address and remember it so that I can put it back when I'm done. So this value right here, whatever bits it has, I'm going to take those bits, copy them onto the stack, push them onto the stack. So I take these bits, I write them down here. This is a little note to myself that says, hey, when you're done, take these values, put them back in EBP, because you want to put everything back where it used to be. So I'm taking the old value of EBP, pushing it onto the stack. That's why this arrow points to the same place as this, because this memory box and this memory box, they both have the address of the top of the main stack frame. So that's another value that I saved on the stack, so that when I change the registers, I have their original values. And as always, when you push something, ESP goes down. That's just something that always happens. OK, so now that EBP is safe and EIP is safe, both of these values are safe. I remember their old values. Here's a reminder. Here's a reminder. They tell me what the old values are. Now I am clear to move the registers as I want. So here we go. This is before. This is after. All the registers drop down. So here's before. We were pointing at the main stack frame and the instructions for main. Now they all drop down. Now EIP points at the code for foo. EBP points at the top. ESP points at the bottom of my new stack frame. So To give you a before and after, EBP used to be at the top of the main stack frame. Now it's at the top of the new stack frame for foo. ESP used to be at the bottom of the main stack frame. Now it's at the bottom of the foo stack frame. And finally, EIP used to point at main. Now it points at the code for foo. So all three of my registers changed. And this is what they look like before and after. So that's all the registers moving down. And a question that people always have at this point is, you forgot to save ESP. And it's true, you could save ESP if you wanted to, but the specific design that we're doing is actually going to allow us to skip saving ESP. ESP is actually going to naturally move down and move back up as a consequence of our design. So if you wanted to save ESP, you could, but I'm going to not save it because in our design, ESP is just going to naturally go down and naturally go back up as I pop everything off the stack when I'm done. So the punchline is, I saved everything as I went. This is a saved value. This is a saved value. Then I changed all the registers. This used to point up here. Now it points down here. This used to point up here. Now it points down here. This used to point here. Now it points here. And I've created a new stack frame for foo to use. And now foo can do whatever it wants to do. It can put local variables here. It can vandalize this space. Whatever it wants to do, foo can use this space to do its computations. So local variables, scratch space, whatever it wants to do. And at the end, when we're done, we need to put everything back where it used to be. So EBP is going to go back to where it used to be. ESP is going to go back where it used to be. EIP is going to go back where it used to be. So all of the values are going to be restored. These three memory boxes hold the original values before we called foo. And you might say, how did I do that? How did I take this memory box, which currently holds this address, how did I put the original address back? And how did I put the original address back here and back here? Remember, we went through all the effort of saving the old value here and saving the old value here. So we're going to take advantage of the fact that these two values got saved so that we can restore all the registers back. So I basically just spent 20 minutes saying, you should save your work as you go. Anytime you change one of these memory boxes, just save the value inside before you change it. That's the key. That's what makes all this stuff work. OK. So as mentioned before, you might be a little bit suspicious that we didn't move ESP along with everything else. And the reason, or rather, we didn't save it. And the reason why you don't have to save ESP is because it's going to naturally move down and move back up as a consequence of the way we built this. So you could save ESP. Turns out it's unnecessary, so we didn't bother. Another point that I'll call out is when you pop something off the stack, you could overwrite it with all zeros, but you'd also just be lazy and leave the old value there. It's below ESP, so all this stuff is in the abyss. It's undefined memory, so leaving the old values there doesn't really matter. If you wanted to, you could clobber them out with all zeros or something, but we're lazy, so we don't bother. And one final note before I take a couple of questions is the EIP that I save on the stack, sometimes people give it a fancy name. They call it the return instruction pointer, RIP. That's just a fancy way of saying this is the thing that's going to go back in EIP when I'm done calling the function. And likewise, this value also got a special name, saved frame pointer, SFP. And it basically just says, when you are done and you want to return from foo, take this value, stick it back in EBP. So if you want to, you can just call them the value that's going to go back in EIP and the value that's going to go back in EBP. But people are lazy, so they call them RIP and SFP. So those are the steps of the function call, kind of at a high level. Next time, or in the next video, I guess, I will show you how this works in much more gory detail. But this is kind of the high-level picture of what has to happen.